Hello. In this video, it is a fairly short video. I'm going to talk about different types of functions that we have in Rust. So basically, we have three kinds of functions. So we have the simplest one is function item. We also have function pointer, and we have closures. And after these, we are going to talk about function fn, fn once, and fn mute. Not mute like this, mute like this. So a function item is basically when you use this syntax to create a function. These are stateless, they have no state, and I think they're zero sized because in compiler, basically, a function item is just an internal symbol for compiler to point at a chunk of code in compiler code in code. So basically, this main so the compiler comes, parses everything, and parses the whole project. And when you call main, for example, imagine we have another function. Let's say we have this function sum, huh? Takes no argument, returns no argument. If I do sum in here, sum is not a different function, a different pointer or something in memory. It's zero sized. Sum just points to this, and compilers knows where is this function is going to be located in the binary of our application. So it will just point that sum into the location in the binary, right? So if our imagine this is our binary, roughly speaking, if we imagine this is our binary, sum is just pointing to line 7. So sum is saying line 7 contains this, go here. So it's zero sized, and it has no allocations and everything, and it's a stateless. So this is a function item, the simplest form. We already have created thousands of them if you write Rust, because it's basically the syntax we use to create functions. We are creating function items, basically how compiler sees functions and works with them. We also have function pointers. A function pointer is more of a general thing. Maybe I should actually do it after closures. So closures are, we have seen them in other programming languages. So let me create one. So I created C closure. This is a closure. You see, and it has this type. This type is annotating that this is a closure. Let's get a i32 and return that i32 power of 2. Can we do this? So now if you take a look at this type, it says I take i32 and return i32. So what is a closure? A closure is also a function, but closures also can capture their surrounding environment. So they are stateful. What I mean? So if I delete these lines, if I create an x, which is 2 in here, and I say this is an i32, I can use this x in here. See? So I can use this x in here. So my closure is stateful, and it has reference to its surrounding environment. So closures can be looked at like a method on a struct, where struct is their surrounding environment. So if this closure was a function on a struct that has x in it, so let's say imagine surround, and surround has an i32. If we had impl for surround, and we have this function in here, I could, reference it by self.x, right? This is the same thing basically in case of closures. They have access to surrounding environments. So if you have written Rust already, you know that with this idea, you're probably asking yourself, okay, So if closures are accessing their surrounding environments, so how about the lifetime? Who owns the data? So we have multiple or different types of closures, and they can be shown with these traits. But before we go to these traits, let's see. So now x is just, we're just reading x, right? We do not modify the value of x. So we can think of it like a reference, an immutable reference to surrounding environment. So if I have just ampersand self, it's like that. What if I change the value of x? So I do x equals a, right? Because, okay, so if I do mute in here, should work, right? So now C has the same type, but this closure is already changing this value of x. So now I have a mutable reference to my surrounding environment. So for example, I cannot do many things that I could do before with the previous version with this version, because for example, I cannot pass this in multiple threads because I'm changing the surrounding environment. This is really important to consider. There's also another thing, which is move block. So in here, if I do move, capture closures environment by value, right? So we have already seen, so let's have actually C by value. Let's see by mute ref, which is a I32, for example, x equals a. I don't know why it's not formatting this. Okay. Almost the same thing by not mute self, mute ref. So it's just, no, a times x, power of x. So now I have 3 versions of closure with the same type, but this version is basically, can I do mute? No. I wanted to do this more explicitly, but I can't. So the first version just captures the surrounding environment, but no mutable reference, just a simple reference. I can just read my surrounding environment. This is probably the most used one. Then I have the capture closure with mutable reference to the surrounding environment. I'm changing something in my surrounding environment, so I'm limited now because Rust gonna check this and is not gonna let me pass. And it's, you know, it's normal. I mean, if I pass this into multiple threads, it's not gonna work. And finally, I have this capture by value, and in here I'm basically moving or basically passing the ownership of this x and all the surrounding environment into this closure. So when it is done, if I want to work with x, can I, isn't it going to move into here? Oh, I didn't call this C by value. So if I do call this as one, cannot borrow C by value. Why you need this mutable? Okay. So now, do you have x? Aren't we passing this into here? Drop x. So if we have data, we have closure, and we do move, the surrounding environment data is owned by closure now. So this x should be owned right now. I don't know why we have access to this. Let's actually try to run this code. Weird, because it's basically suggesting that data is going to be owned by disclosure and shouldn't be any available anymore. Maybe we didn't choose a good data type for this. Maybe if this x is a vector of I32, for example, and no, if I do x dot len, for example, yes. So the problem was that I32s themselves, since they implement copy, I think, they basically, when I'm capturing this by value, they basically copy themselves, but the vectors are not doing this by default. This is not the default behavior for a vector, and this is correct because you don't want a giant vector every time copies itself around. So yeah, this is pretty much what happened. So we have 3 types of closures. Okay. So we have these 3 types of closures. We have, remove this. Okay. So we have by reference, by mute reference, and by value, which we use move keyword in here. So now let's talk about function traits. And so imagine we want to write a map function. We have a map function in iterators, but let's imagine we want to write it specifically for vectors for some weird reason. So if we have a vector, so it's a we have a vector of type t, and also, so we want something to map from, basically map from t, right? Map from t to another t. Not necessarily t, but let's imagine for simplicity. And this is called f, right? This is not a valid Rust syntax, I know. So we cannot write it like this. So how Rust, how we could do this in Rust is using function traits. What I mean by function traits. So if I have added another type in here, so I can say f, and this, actually maybe that was valid Rust. So let me just try this again and see if we can use this. Yes, this is valid Rust, and it just accepts function items. I was wrong, but and actually we can use this. So I'm going to say v.map. Can we do v.iter? Iter into iter. I think into iter creates iterator from value. Yes, I now want to do map. So map takes itself, you see, it takes a f, which is f and mute. We just pass f, and it should work, right? Okay, so we can do this like this, but we can pass to this function map. We cannot pass a closure like we can for the iterator map itself. So if I want to call this function pass x, I cannot pass a closure here because I cannot, because the type is not that, and it says only functions that take t and returns t, and functions by I mean function items, but I want any types of function, so I need to have a more generic view, basically. So we are going to talk about functions, function traits. So what is a function trait? It's a trait that this version of call operator takes an immutable receiver in. So we have 3 versions of this. Sorry for the disruption. So Yes, so we have this this function traits thing. So we have three of them. So we have function, we have fun, fn once and fn mute, right? So fn takes an immutable receiver from the surrounding environment, from the self, which is surrounding environment. So this is an immutable receiver, right? Come down. Okay, fn once takes a by value receiver, right? So basically it takes the ownership of the surrounding environment, okay? And finally we have fn mute, which takes a mutable receiver. And now you can see how we can map these three to these. If I just change this, they will be mapped completely in the same order. So a closure that captures the surrounding environment just by a reference, not mutable, not by value, it's just implementation of fn. A closure that takes a mutable reference to the surrounding environment is basically fn mute. And finally, a closure that gets the ownership of the surrounding environment is fn once, because we can just call this once. If we take the surrounding environment ownership, after we are done in the closure, they are going to be destroyed because the lifetime ends there. So basically this is how you you can use this in a more generic way, so you can basically accept anything, because all of these items, closures, and function pointers can be coerced into this if they are if compiler is capable of if the compiler is capable of doing that, coercing these. It can coerce anything, any of these into this. So this is a more generic approach. So if we want to write the var thing in here, we are going to say f is just going to be, for us, since we are going to take the ownership, I'm going to say fn once, right? Fn once of t that returns t. Now we can pass anything in here. So I can say I32 a, and for each one I'm gonna say return a plus 2. Type annotation needed. Cannot infer the type f. I cannot infer this. Why? Oh, because I didn't say f is here. You see, we cannot pass a function item here. But if I say this is f now, this should work. Right. It says I can also, restrict this bound and anything, but it's okay. So now we know what are different types of functions in Rust, and most of the times you probably, if you want to pass something, most of the times if you want to accept something as which is a function, you're probably going to use one of these based on what you intended to do. You probably won't going to use function items a lot. Only you're just gonna write them, but you're probably not going to pass them around. Same goes for closures and function pointers. Most of the times you're going to use these traits, so these are really important to know. Yeah, this is it. This was a short introduction to function pointers and anything in Rust. If you like this content, subscribe and comment me, and you can also contact me on Twitter, mail, and etc. Thank you, and until the next video, goodbye.